All right, in 706, we're going to talk about what we can do with those formulas now that we know how to write them. So we're going to do the back third of this chapter, which are formula calculations, where we're either doing calculations with the formulas that we found or the procedure that we use to come up with the molecular formula for unknown compounds. But we're going to start off with the molar mass of compounds. Now, we've done the molar mass of elements. And we said that the molar mass of elements was the average atomic mass, but the unit was particular. So over here, they show it as grams per mole. Remember, that's the same thing as grams per mole. So we write grams on the top and mole on the bottom, and that's always implied. So you're talking about X number of grams in 1 mole. So at this point, you should know that all of these things are always the amount we have in 1 mole. How does this compare with the what we saw for elements, the periodic table mass, and that was in atomic mass units, but the molar mass is in grams per mole. So what we do, we have an example over here to find the molar mass of a compound, is we write down the average atomic mass. So they went to a lot of decimal places here. They had 15.9994 for oxygen. I would have rounded that to 16. Here, hydrogen is 1, and there's 2 hydrogen here. So we see that the molar mass for water is 18.0153 grams per mole. We're always going to round it to 18. So let's do sodium. First thing you want to do is make a list of all of the elements that you have. So I have sodium, I have sulfur, and I have oxygen. Then you want to write the number of each one that you have. I have 2 sodium, 1 sulfur, and 3 oxygen. We're going to multiply that by the average atomic mass in grams per mole, and I'm going to round sodium to 23. Sulfur is 32, and oxygen is 16. We multiply those out, and then we're going to add them together. So this is 46 plus 32 plus 48. And when I add that up, I get 126 grams in 1 mole. Or I could say the molar mass for sodium sulfite is 126 grams per mole. All right, so for a practice problem, let's have you do glucose. Do you remember that glucose, the formula from biology? C6H12O6. All right, pause the video and try to work this out and see how you do. Okay, did you take a stab at it? So we're going to list our elements. We have carbon, hydrogen, and oxygen. Carbon is 12, hydrogen is 1, oxygen is 16. I have 6 carbon, I have 12 hydrogen, and I have 6 oxygen. When I multiply that, I get 72, 12, and 96. And when I add that up, I end up with 180 grams per mole. So another thing that we can do is, now that we know how to find the molar mass, is we can do the percent composition by mass. So if I asked you to take a car part and there was a metal piece on it, the whole car part weighed 10 pounds, and the metal piece was 3 pounds, and the center block that was plastic was 5 pounds, and there were some other pieces, and I asked you what percentage of the block is the metal. Well, 3 pounds out of 10 is 30%, and the plastic would be 5 pounds out of 10, which is 50%. So that's the same concept that we're going to do here, and I have silver sulfate listed out. So in order to calculate the percent composition, the first thing I need is molar mass. So let's do some steps here. So step 1, we have to find the molar mass. Find the molar mass. All right, so I have silver, I have sulfur, and I have oxygen. I have 2 silver, I have 1 sulfur, and I have 4 oxygen. Oxygen is 16, sulfur is 32. We've already established that. And when I look up silver, I see that I have 108. All right, when I multiply those, I get 216, 32, and 64. I add those up to get the molar mass. My molar mass is 312 grams per mole. Now I want to calculate what percent of the compound by mass these are. So how am I going to do that? Well, again, with my car part example, I took the metal portion, the 3 pounds, and I divided that by 10 to get 30%. I took the 5 pounds, I divided that by 10 to get 50%. So here, what I'm going to do is I'm going to divide the mass. So step 2 is to divide the mass of each element by the molar mass. And multiply by 100. So my molar mass is 312. The mass of silver is 216. So I'm going to divide this by 312. I'm going to divide this by 312. And I'm going to divide this by 312. And before I enter it in my calculator, I want to multiply it by 100. So I end up with, just going to move this a little bit. 216 divided by 312 is 0.69. And when I multiply that by 100, I get 69%. 32 divided by 312 is 0.1. This is going to be 10%. And 64 divided by 312 is 0.21 or 21%. So what this means is that if I had a mole of silver sulfate, 69% of that, let's say I had 10 grams. 6.9 grams is going to be silver, 1 gram is going to be sulfur, and 2.1 grams is going to be oxygen. So I can look at any amount of this compound and I can know what it's going to be. All right, let's do a sample problem here. So let's do sodium nitrate, NaNO3. So go ahead and pause the video, work this out, and then when you come back, we'll look at the solution. All right, did you give it a try? All right, here's what we have. We're going to find the molar mass first. We've got sodium, nitrogen, oxygen. I have one of these, and 3 of these. This mass is going to be 23. This mass is going to be 14, and this is 16. So when I multiply this out, I get 23, 14, and 48. I add that up and I end up with a molar mass of 85 grams per mole. Now I divide each of these by the molar mass, and I multiply by 100, and I end up with 27.1%, 16.5%, and 56.4%. Is that what you got? So if I had 10 grams of sodium nitrate, I would have 2.7 of that would be sodium, 1.65 would be nitrogen, and 5.64 grams would be oxygen. Okay, that is getting us into formula calculation territory, and we'll move on from here. Thanks for watching.